Grip strength is widely used as a simple and reliable way to estimate overall health and predict long-term outcomes. It is easy to measure, strongly correlated with survival, and reflects important aspects of system capacity. At the same time, it represents a specific type of strength, primarily related to upper body force and neural activation. The body operates through multiple systems that support different functions, including movement, balance, and large-scale coordination. Grip strength reflects one of these capacities within the system. To understand how strength supports real-world function, it helps to consider how these different systems contribute to what the body is able to do. Grip strength reflects how effectively the nervous system activates muscle. When force is produced, the brain recruits motor units, which are groups of muscle fibers controlled by a single neuron. The number of motor units activated and the coordination between them determine how much force can be generated. This makes grip strength a useful indicator of neural efficiency and muscle activation in the upper body. It shows how well the system can produce force through coordinated signaling. At the same time, this type of activation is specific to the task being performed. It reflects one form of strength within the broader system, rather than how all forms of movement and force are organized. Strength is expressed within specific movement patterns. The nervous system organizes force production based on the task being performed, which means strength is not a single, general output. Different movements require different coordination, joint involvement, and muscle activation patterns. Grip strength reflects force production in a specific context, using the muscles and coordination required for that task. Other forms of strength, such as standing, walking, or stabilizing the body, rely on different motor patterns and system demands. This means strength is distributed across multiple functions, each supported by its own structure and coordination. Grip strength represents one of these functions within the broader system of how the body produces force. Lower body strength supports how the body moves through space. Movements such as standing up, walking, climbing stairs, and maintaining balance rely on coordinated force production across the hips, knees, and ankles. These actions involve larger muscle groups and require integration between strength, timing, and stability. The nervous system organizes these movements differently from isolated upper body tasks, using broader patterns of coordination to manage body position and momentum. This type of strength reflects how force is applied to support movement and control. It represents another dimension of system capacity, working alongside other forms of strength to allow the body to function across different demands. Movement depends on how multiple parts of the body work together as a coordinated system. Rather than acting in isolation, joints and muscles contribute in sequence to produce smooth and controlled motion. This is often described as the kinetic chain, where force is transferred across segments of the body during movement. Effective movement requires timing, coordination, and communication between these segments. The nervous system organizes this integration so that force is distributed and controlled throughout the body. This type of coordination reflects how different systems combine to support function. It represents another layer of capacity within the overall system, contributing to how the body performs in real-world conditions. Stability depends on how the body maintains balance and responds to changes in position. Postural control involves continuous adjustments made by the nervous system to keep the body aligned over its base of support. When movement occurs or the environment changes, reactive balance mechanisms respond quickly to prevent loss of stability. These responses involve coordination between sensory input, such as vision and proprioception, and motor output to adjust muscle activity. This process allows the body to adapt to shifting conditions in real time. It represents another component of system capacity, working alongside strength and coordination to support controlled movement and reduce the likelihood of instability. The body continuously allocates resources based on the demands placed on it. This process, often described as adaptive prioritization, allows the system to maintain capacities that are used regularly while reducing emphasis on those that are not. Strength, coordination, and stability are supported in proportion to how often they are required in daily activity. The nervous system and muscular system adjust together, reinforcing functions that are repeatedly engaged. This does not occur through a single measure, but through multiple systems responding to patterns of use. It represents how the body organizes capacity over time, ensuring that the most relevant functions remain available within the broader system. Strength is not a single quality expressed the same way across all situations. Different types of strength support different roles within the system. Grip strength reflects localized force production and neural activation in a specific task, while lower body strength supports movement, stability, and force transfer through the body. Other capacities, such as balance and coordination, contribute to how that force is applied and controlled. This reflects system specialization, where each component supports a distinct function. These components operate together rather than replacing one another. Understanding strength in this way shows how multiple capacities contribute to overall function within the broader system. Strength reflects how multiple systems work together to support function. Grip strength provides a reliable marker of certain capacities, particularly neural activation and localized force production. Other forms of strength, such as lower body force, coordination, and balance, contribute to how the body moves and responds in different situations. These capacities do not replace one another. They operate together, each supporting a different aspect of performance. This integration allows the body to adapt to a wide range of demands. Understanding strength in this way highlights how individual measures fit within a broader system, where multiple components contribute to overall capacity.